Yeah, first of all, welcome everyone. For those that I didn't get a chance to speak to, I'm David and I work at Validus, currently leading the technology department, and I'm joined by Fergus, who's leading our platform team. So we'll do the first talk in 2 bits. One is a kind of like more general introduction to what we do, which is the part I'm doing, and then Fergus will deep dive into the first use case which we implemented in Rust at Validus. So Validus is a finance firm. We do a full product suite from order management, trade execution, all the way to like post-trade management and risk management, which is not the exciting part. The exciting part is that due to that, I guess we have a fairly large range of different services and integration patterns at Validus. We're fully on AWS, so operate in a cloud-native environment. Previously, before adopting Rust, we use Python exclusively, pretty much, apart from a few like outliers in using JVM languages like Kotlin. And in terms of workloads, we have a good mix of like external vendors sending us data, which we process in real time in some cases. We run large simulations for risk. And we write a lot of traditional web services, so like RESTful APIs, gRPC services, and we have a front-end application as well, obviously, which is not very relevant to this. So in terms of Rust adoption, we started in the second half of last year, after like a long time debating what language to adopt to make our stack a little bit more performant. We considered Kotlin, Go, and Rust. Rust has been a passion of mine for a long time. And we eventually, I guess like the concern was the maturity of the ecosystem, but what gave me the push to finally like go for it was basically AWS releasing the SDK, the official SDK, which is still in developer preview. I thought it would not take that long, but we've been using the developer preview for a long time in production as well now, and it's been highly successful. So no issues there. So what has been a success, I thought I would just talk you guys through what I've found to be very beneficial in our Rust adoption, and then some of the challenges we faced. So what has been a success is rewriting our real-time pipelines in Rust. Obviously, compared to Python, it has been a lot more performant. In terms of like parallelization, it's become a lot simpler to do things in the right way, and our systems haven't really been breaking since we adopted Rust in that space. And then AWS Lambda-based services, so we do use quite a lot of serverless stuff, where we struggled a lot with cold starts and Python, like package bundling. And there's an amazing package, Cargo Lambda, which we started using for deploying Lambda-based services written in Rust, and that has been a really pleasant experience as well. And I think one of the largest benefits has been modeling complex financial models. So using algebraic data types that Rust has, and sturdy for serialization. We're actually quite unique, I guess, in that our payloads tend to be quite large, and Python has been a bottleneck for serialization, deserialization in some of the cases. So we moved some of the services over to Rust and have seen a benefit there. In terms of challenges, there have been like a few cases where we had to write stuff ourselves that otherwise wouldn't have had to integration with third parties. So for centralized logging and tracing, we use Datadog, which doesn't support Rust out of the box, but in most of these cases, we've managed to work around it in one way or another. Datadog supports open telemetry to some extent, so we use open telemetry in that space. We ingest data from Bloomberg, bpipe, which is a real-time offering for market data from Bloomberg. In those cases, we sometimes just don't use Rust for the first service that hits us, and then ingest the data from there, put it in some queue or like Kinesis or whatever, and write the rest of the stack in Rust. And then the big one, so our primary focus is risk management, where we use like heavy simulations, large-scale simulations, where the Rust ecosystem is not quite there. So what we're experimenting with now is using Ray in Python, which is a distributed compute platform. write the performance critical parts of the code in Rust and interface with Python and use Python for orchestration of these distributed workloads in Ray. So that's kind of where we are now. The very first use case we productionized using Rust was the real-time market data feed from Bloomberg, which is why I mentioned Bloomberg B-pipe here. And that's what Fergus is going to get into in more detail.
Cool. Thank you. So yeah, this is sort of a very light actor model that we built on top of native Tokyo kind of threads. So as David mentioned, we have Kinesis. On the other side of this is a Python supported ingest system from them. Everything gets loaded into Kinesis and then comes in through a custom wrapper that we wrote to integrate the Kinesis consumer library with Rust. There's a link to that on the next slide if anyone's interested, or we can chat about it later. All that really matters here is that we have real-time market data sort of arriving. We have this actor that kind of looks after that. It's kind of triggered by these incoming records coming off Kinesis. It molds that into a strongly typed struct and puts that into the inbox queue kind of thing. We can see that it's right now just the unbounded Flume channel. Probably later on would implement back pressure with a bounded queue, but for now that was all right. It's quite predictable. So, importantly, we have this set of incoming market data. On the other side of it, we have subscription state where people or other systems can notify it what they're interested in. So we have either kind of general spot rates coming in or more complex transforms that people are interested in that are adjusted by the market data. That might be a combination of various tenors. So the subscription actor kind of looks after that. Its job is to periodically refresh the subscription state. Then the core of it is really these calculator actors. So a calculator basically takes the incoming data as well as who's interested in its specific calculations, and then receives it, checks the relevant active subscriptions, runs the active calculations that are required at that time, and then disperses that to the relevant subscribers as well. So you can kind of see the process records at the top there is the incoming market data. We try to make it quite segmented. We had a lot of different teams working on this. We had kind of my side of the platform side that was heavily focused more on the AWS interfaces, so getting the data out of Kinesis into the system in a way that was easy to work with, and then kind of getting that data out into whatever downstream service required it. So we kind of try to build these really nice, clean interfaces where quants or other financial developers could just understand, this is the message I'm receiving, I can do my work with it, and then send it on to some other actor that knows how to get it where it needs to go. And that worked really well for us, and the sort of piping of it all turned out pretty simple. Like you can see, we kind of have the subscription state, which is a watch channel, looking after the current state of subscribers. You have the market data inbox, which is Flume, and then some piping to kind of get them all the relevant information that they need. And then that sort of just runs forever. In terms of scaling, in terms of you have multiple different threads running, so you can vertical scale quite aggressively with this, which was a major advantage over something like Python, where you're fighting the interpreter lock the entire time. And yeah, that was a success all around, I think. And I think we solved quite a few hard problems at the top to make these calculations quite easy to iterate and expand on. The hard problems are now solved. We can now focus on interesting and unique calculations to then give to our clients with downstream systems without ever having to worry about the rest of it again. Cool. Anything else?
No, I think.
Yeah, so just some extra links. I'm not sure if we're going to send these slides out or what the plan is. But yeah, we have our implementation of the Kinesis client library in Rust, if anyone's interested in that. We have an Amazon blog post in partnership with Bloomberg and AWS on how we built the actual ingest B-pipe integration side of things, and then Cargo Lambda, which David spoke about earlier as well.
Yeah, I guess just to add to the first one, so you can communicate with Kinesis through the SDK, so that's not an issue. But what KCL does, so the Kinesis client library that Amazon provides, is the kind of like whole load balancing side of things, and like interacting it with a more meaningful way than the low-level SDK. And that's kind of like where Rust didn't have support.
Yeah. So you have support for kind of like shards, and if you have 2 consumers but 5 shards, it'll automatically juggle who's responsible for which shards, checkpointing, that kind of thing. Yeah. Cool.